Hi, I'm Russ Lindsay. I work with Stack Velocity. We're a systems integration company that we deal with specifically large-scale deployments and small-scale deployments as well, actually, for customers who are utilizing various brands of hardware, various brands of OpenStack, Hadoop, other kinds of software. So essentially, we customize and build stacks for people, or they can use some of our reference architecture designs, hardware and software agnostic. So I'm trying to make sure that everybody understands this is as opinion-free as possible approach to thinking about the things that you need to talk about when you're going to start buying hardware for OpenStack. A few things that are really important. I'm going to assume that a lot of people who are listening to this are planning to try to deploy OpenStack possibly for the first time. Big things that you need to really consider ahead of time is your workload, your budget, and how important is efficiency to you. If you're a smaller scale customer who maybe is deploying one rack in a colo, power efficiency probably isn't super important to you. But if you are somebody who's going to be deploying at scale, filling an entire data center, power efficiency becomes a very big deal. People are more and more concerned about, I guess, A, being green, but also just straight out the cost associated with deploying hardware and having huge amounts of sink in operational costs. Lastly, is a big thing you need to think about is open source tools and how comfortable are you with them. There's two approaches. One is to go with the branded OEM style hardware, and the second is to go with an unbranded, or some people use the term white box style hardware, something that is less expensive. You got pros and cons of both. White box is typically, or unbranded is typically something that is going to require a little bit more work and a little bit more knowledge of how to use things like open source tools. If you go with the more traditional OEM style hardware, you've got a lot of tools that are baked in already that they're providing for you that are going to help you deploy the hardware, monitor your performance, monitor your health of your systems, control power, all those kinds of things. With the unbranded servers, typically you end up needing to learn how to use IPMI tool command lines, things like that. So stuff that you may not think about when you're talking about software stacks is, honestly, you've got to be able to control the hardware that they're on effectively. I'm going to skip a couple of these things and go kind of straight to the point. Biggest things on processors are, consider your budget. You can spend as much or as little as you want. You can buy, you can buy a $3,000 processor, you can buy a $300 processor, and ultimately, usually you can deploy more machines with lower cost processors and actually get more performance, more benefit out of your stack that way. Basically, my opinion is go for the sweet spot for cost versus number of cores. If you're going to deploy hardware, think about cores are more important than your clock speed as a general rule for OpenStack. So what you really want to do is consider using maybe the lowest clock speed of a particular range of cores. So if you pick an Intel 8-core CPU, by the lowest clock speed, so you get the most for your money that way. There's the other side of that is, are you brand sensitive? Intel versus AMD versus ARM versus however you want to go about it. Intel's common, most common, but one thing you should think about, and a lot of people do, is one of the benefits of AMD, if you chose to go that way, is that they do have a higher core count on average. And so because cores are important to OpenStack, it does make it a viable option. Memory. Biggest thing is for memory, think about your cost. The reality of it is a lot of people say, oh, well, I only want some 4 gig DIMMs. Think about price parity points, because typically right now, the way the market is, 8 gig and 16 gig DIMMs are about on parity for cost. So its cost per gig is the same. If you actually buy a 4 gig DIMM, you might end up paying 30% more per gig by buying the smaller DIMM. So, and the opposite extreme is true as well. If you go up to the 32 gig DIMMs, you end up spending, substantially more money to fill the slots. So that's really only viable if you really need the extra memory. Start small with your virtual, but don't skimp on the physical memory. It's easy to add memory to your VMs. It's very hard to go back to the data center and add memory to your servers. For the grand scheme of things, you know, your server cost, you're not sinking money in memory. You're sinking money in processors and motherboards and hard drives and all of those kinds of things. Memory's relatively inexpensive. Buy as much as you can afford to buy. Network cards, I'm not going to talk a lot on this. Biggest thing to consider is, are you going to go 10 gig, 1 gig, 40 gig? How fast do you need your network to function? From my opinion, most people are going to use 10 gig. It's kind of standard across the board. You can get a lot of your services on a single NIC that way. Otherwise, you end up with you know, having to manage a lot of cables and a lot of space in your rack, and a lot of switching. And switching, the more you have, the more complicated it is, and the harder it is to make it function. So 10 gig is a good happy medium. Two choices out there really today: 10G base T, which is an RJ45 style jack, which is similar to what your 1 gig connections are. And then there's the SFP Plus, which is used for fiber channel or for there's some copper DAC cables, things like that can be used inside the rack. Most common is SFP Plus. Cost-wise, it's cheaper to deploy, and it's more efficient. It uses a lot less power. But you know, some people are tied down to a specific type of cable that they want to use. It's, you know, so both are viable options. Hard drive controllers. Simplest thing there is get an HBA. Don't use a RAID unless you absolutely need it. Really, the only people who are probably considering using RAID and OpenStack is somebody who maybe has some data sensitivity issues where they need the caching capability of a RAID card. Otherwise, they just need to, you know, if you just need one-to-one disk access, it's the most efficient. Storage requirements, again, it's a relatively simple conversation. Go with SATA drives. The larger, the better for the most part. You know, you can use SSDs for caching, paging, and things like that. But it's you know, for the most part, your storage should be run on larger volume size drives, and SATA is the most economical. Consumer grade versus enterprise. I've seen a lot of customers try to go out and use consumer grade drives from Best Buy and fill up their server, and yeah, it works for a while. But you know, it's something that needs to be mentioned because a lot of people think that they can save some money that way. It's really not the way to go. Your drive life won't be satisfactory. A few more things to consider if you're actually going to be deploying in a data center or colo yourself. The biggest things are cabling, or one of the biggest things is cabling. You've got to manage your cables well. In some instances, you could have as many as 5 network cards in a box. You start trying to manage network cards running to 3 or 4 switches and, you know, 5 different VLAN setups. It can quickly get out of control, and pretty soon you've got a rat's nest that you can't manage, or you can't get in to service your machines when you're done. So pay attention to that, and if you don't know how to do it, it might be worth investing a little bit of money to pay somebody to help you, because it's a relatively inexpensive thing to get done in the grand scheme of what you're trying to do, but it's definitely a skill. If you're not good at it, it'll make a mess. Airflow. This is probably more of an issue for people who are going to buy the unbranded hardware. OEMs spend a lot of time and money making sure that their hardware is good and tested and functional and tuned. A lot of the unbranded stuff, it runs the gambit. Some people are very good at it, some people are very bad at it. And what you need to do is pay attention to airflow, because it's going to dictate how much power the system draws and how well it performs. If you, biggest thing to do is just open the box and look and see if there's an air duct over the motherboard. If there is, you know, you're probably, somebody at least gave some attention to it. If there isn't, step back and start asking, why am I buying this piece of equipment? Because it's probably completely inefficient and maybe not what you want to use at all. And then the other 2 big things to consider are firmware and BIOS. These are things that nobody talks about when they start talking about OpenStack, and you know, it's how easy it is to deploy, and everybody's got their engine that deploys it, and it's all super simple, and you can do it in an afternoon and you'll be happy, right? The issue is that 80% of the work needs to be done to make it function prior to even trying to install OpenStack. What you end up with is in a lot of instances is buying, especially if you buy cheaper hardware, you find stuff that doesn't have drivers that work with OpenStack, and you don't, you might not be able to get them to work at all. So it's best to check the distribution of OpenStack that you're going to be running, compatibility list to make sure that your drivers and firmware are going to be functional with it. BIOS settings is another big issue. There's a lot of things that need to be configured for networking, in particular, server management, those kinds of things that it's challenging to get right. And so the best thing is to go ahead and build a file, basically, to be able to flash the BIOS configured correctly onto your servers. That way, everyone's the same, and it's always correct. You don't run the risk of human error changing things up. Lastly, is going back to the open source tools. If you're used to using OEM hardware, you've got tools out there like DRAC or ILO or some of the other proprietary stuff that's used to manage your servers and monitor and turn things on and off. That functionality is all still there through open source tools, but it's not as easily usable from somebody who is not used to it. So you're going to have to consider taking some courses or reading some reference material or something on IPMI and some other monitoring softwares that are out there, because most of the stuff is done through command line, and it's not a pretty UI that you can follow. Anyway, I think I'm about out of time here, so I'd like to thank everybody for listening, and go enjoy deploying your OpenStack.